Welcome to the Maritime Executives podcast series, In the Know. I'm Tony Munoz, Editor-in-Chief. Our Executive Corner podcast will provide conversations with top executives concerning events and issues that are shaping our industry today.
On today's episode of In the Know, we'll be speaking with Martin Kitts van Heyningen, CEO of KVH Industries. Listen in as he talks us through the rapid expansion of mobile connectivity in the maritime industry.
Good morning, Martin. It's good to have you with us.
Good morning, Tony. Great to be here.
Yes, thank you. We are understanding that the maritime satellite communications industry is expected to grow by 9% over the next 5 years to become a $4 billion industry. What's driving this robust increase?
Well, I think it's really a confluence of factors. We start with COVID, introduced new ways of working for people, working remotely. At the same time, you had seamen who were isolated on ships for months and months at a time, unable to get off or rotate crew. So crew welfare suddenly became much more important. You've got new pressure on the environmental front with CO2 reductions and the IMO efforts to curb, CO2 emissions on ships. That requires data and analytics and, measurements. So I think what you're seeing is generally, the entire industry is trying to run their businesses more efficiently, and that requires data. So you've got, on the one hand, demand for data, and then on the other hand, you've got new equipment coming out, which is faster and smaller and cheaper, and it's kind of coming up against a natural product replacement cycle where the equipment that's been on board these ships is now 15 years old. It was developed for L-band satellites, way back when. And so it's really just all these factors coming together in this sort of tsunami of demand.
It's pretty incredible. There's a report that said that maritime SATCOM, there was a general lack of awareness about the advances in communication that are hampering market growth. But do you agree with that?
I don't know. It's
talked about.
Yeah, I mean, the market, as you just mentioned, is growing pretty quickly. So I think people are understanding that there's tremendous benefits to be had. But, perhaps what they're talking about is that there are new technologies coming. And, whenever there's new technology and old technology and people think they should wait for something that's even better still, that confuses people who aren't, dealing with it on a day-to-day basis. So sometimes, just too many options or too many choices leads to confusion and kind of delay. But in general, I think people have gotten the message that you really can't run a modern business nowadays without, high-speed data, high-speed internet access.
Well, I can certainly remember when when we were involved with the offshore industry, there were a lot of concerns about the cost of having that communication for the crew. And, it advanced to the point where crew members could help their daughters do homework and converse with the wife about the bills or whatever else that was going on in vacation. So that's been a great advancement. But even today, it's just gotten to be so much more efficient. And what are some of the benefits of deploying the Internet of Things solutions on commercial vessels?
Yeah, you brought up a good point, Tony, that, back in the day, it was so expensive. And, for the last, 30 years, the shipping industry and the commercial maritime industry spent a lot of effort trying to figure out how not to transmit data, how to, compress files and how to, trickle data out or, only do it when they get to shore. So it's really a mindset change that, that was required for people to realize that, the benefits and the lower cost, and it now means that, you really need to embrace this technology.
Absolutely. But again, what are the cost benefits of Internet of Things? I've heard that term, Internet of Things,
right,
over the course of the last year. And, I'm beginning to learn it and understand it. Perhaps you know more of what they're saying.
Well, it really talks about, machine to machine connectivity. So the number one underlying benefit is efficiency and economics, saving money. So by being able to transmit data off the ship, I mean, a commercial ship nowadays, if you think about it, it's kind of like the poster child for an IoT application, because it's a large, expensive piece of equipment floating in the middle of the ocean. There's no IT staff on board. There's there's very little access to outside help. So being able to transmit data off the ship is really a huge advantage. And modern equipment nowadays is so complicated, it's all run by software, it has sensors and everything. So it gets more and more unmanageable for the crew to be able to keep these things running. So by changing the paradigm and giving them the ability to transmit this data off the ship, suddenly you have the ability to get world-class experts to look at it in real time. Whether it's a repair, so if you can repair something underway or prevent something from breaking down, you might save a $5,000, technician trip, flying to Singapore, to repair something when you're in port. And also the advantage is that you suddenly have the ability to do things while you're underway, which might prevent the maintenance event in port, which might mean your ship, which is now chartering for $100,000 a day, isn't out of service for a day. So it's all of it comes down to economics,
Right.
including things like preventative maintenance, predictive maintenance, even where you look at the data and decide that, you don't need to service the equipment, even though it's scheduled to be serviced, because it hasn't, it's not necessary yet. So in other words, changing your oil when it's actually required, not because it's been 10,000 miles since your last oil change.
Right. It's interesting. Over the last year, we've heard about a lot of people getting rid of their older tonnage, and the shipyards are full. So I would imagine the technologies that are being deployed or integrated into these new systems to speak to exactly what you're talking about. The industry is upgrading as your industry is upgrading. So I think it's a perfect storm for that. Currently, there's a lot of buzz about the LEO constellation. What's the difference between the GEO and the LEO, and what role will LEO play in maritime?
Yeah, that's really interesting technology that's coming, and it's really a large change. So fundamentally, a GEO satellite is a satellite that orbits the Earth. And it orbits the Earth at a speed that it takes it 24 hours to circle the Earth. And of course, the Earth also spins on its axis every 24 hours. So to an observer on the ground, it looks like the satellite is stationary in the sky, even though it's moving at 3 kilometers per second, orbiting the planet. A LEO satellite, on the other hand, is very close to Earth. So it has to travel much faster to to prevent itself from being pulled in by Earth's gravity. So it might be traveling 7 kilometers per second because it's so close to the Earth. So, and to an observer on the ground, the satellite is whizzing by overhead, looks like it's more like a jet airplane flying overhead, going from horizon to horizon within, say, 2 minutes. So, and then every 2 minutes, you need to, point your antenna at a different satellite to pick up, the next satellite that's coming by. So from a technology point of view, they operate the same way. There's a Earth station, it points at a satellite in space, and that bounces off the satellite and goes to your ship in the ocean. The difference is that because the LEOs are much closer, you need many more of them, but the advantage is that you have less latency, because radio signals can travel at the speed of light. So you would think, that's so fast, it shouldn't make any difference. But it still takes about 600 milliseconds for a radio signal to go from, your ship out to a GEO satellite and back to Earth. And that's, 0.6 of a second. So if you're watching a video, it takes half a second before the video starts. That doesn't really matter much if you're watching a movie. But if you're doing something interactive, like gaming, or if you're doing web browsing where there are a lot of objects that need to get fetched, actually the latency matters more than the speed. So it really depends on the application, but that's sort of the fundamental difference between the two technologies.
Now, the LEO is just coming on board, correct?
Yeah, there aren't any available yet. So there are no LEO satellites for maritime today for VSAT. There are for Iridium, actually is a LEO constellation that's been around for a long time. But for VSAT, for high-speed internet, there it isn't yet available for maritime. So, but we expect it to be in about a year or two.
I got you.
So the challenge for maritime is, unlike land, with a geosatellite, you can see it for very, very large areas. In fact, you can basically see the full disk of the entire planet from the geostationary orbital location. Whereas a LEO satellite, you might only be able to see a circle of about 500 miles in diameter. What that means is that for satellite internet to work, it's kind of like a bent pipe. You have to see both the Earth station and the ship you're trying to connect. So what that means is that for a LEO constellation, you need a lot of Earth stations. So you need Earth stations, hundreds of them, for example, just in the United States. And for maritime, that's a big problem because you can't put Earth stations in the ocean. So either you have satellites a little bit further away, like what OneWeb is doing, or you try to develop inter-satellite links, which is what SpaceX and Starlink are trying to do to overcome that problem. So that you actually beam the data from satellite to satellite until eventually you're over land and within sight of an Earth station, and you can make the connection to the internet that way.
Sounds very complex.
It's very complicated. I mean, LEO's, it's the most complicated, most expensive way conceivable to bring connectivity, so it's
Right.
very complicated because not only do you need hundreds or thousands of satellites, because they're so close to Earth, they only last for about 3 years, 3 to 5 years. So once you get the constellation up, you need to replace it.
Wow. I did not know. Wow.
It's
Every 3 to 5.
economically challenging,
Yeah.
if, which is a problem for the people developing the systems, that's not really a problem for the people using them. So
Right.
if someone wants to spend all that money, it would be still a good system eventually.
Gotcha. Well, Asia Pacific is forecasted to be one of the fastest growing markets in the world for SATCOM. Is the infrastructure in place to manage that? Or is that what we were just talking about?
Yeah, it's kind of what we're talking about. So for geosatellites, the infrastructure is not a big deal. You need maybe one to handle all of Asia Pacific, a terrestrial hub, or what we call a megapop, where you route all the traffic. Whereas for LEO, you're right, it's the same problem. So you need a lot of infrastructure in each country for terrestrial connectivity, and in order to provide the connection. So not only when you think of all those satellites, when you think of all those hubs, at the end of the day, you still need to provide connectivity. So it's like your local cable internet provider, just because he connects to your house, that doesn't solve the problem. At his, back end has to provide a ton of network capacity so that everybody gets good speeds.
Right, correct. So as that market grows, do you see a lag in the ability to provide them, or it's growing now. I mean, yeah. ships are coming out of the shipyards and they're ready to go to work, and
right.
So
yeah, so
there's
bandwidth is one of those commodities that there's never enough of. Like, no one ever calls me up and says, "Oh, our connectivity is just too fast. We just, don't you have anything slower?" That just never happens. So
right.
No matter how much people have, they'll use more. So if bandwidth becomes less expensive, they buy more of it. And if they have more of it, they give the crew access. And once the crew has access, then they want to do, connectivity with their friends and family. And then they want to do Zoom calls, and then they want to watch Netflix movies, and then they want it in 4K. And, you're back to square one and needing more bandwidth again.
Yeah. So the trends that we're seeing in operational data needs are the crew welfare needs for data. Are they being met? I mean, I guess what I'm trying to say is we're talking about the Internet of Things, and
Right.
and are the crew data needs being met to conduct business? Are we?
Well, there's a pretty big dichotomy out there between sort of the Western European, ship management companies and some of the Asian ship companies, or the Greek. It really varies in terms of how much connectivity they want to provide for the crew, or can afford to provide for the crew, depending on whether it's a tanker or a bulker. So it really varies. But in general, there's a lot more emphasis on crew welfare now. And it's getting harder and harder to get people to go to sea for, months at a time. So there's definitely a focus on it now. So not just for connectivity, but also for media and content, and to keep the crew happy and informed with news from home and movies and things like that.
Yeah,
but compared to the data for operation, so we're seeing what we would call an explosion in data for operations, but and that's for valid business purposes that generate real value to the ship managers and ship owners. But compared to the crew usage, it's a drop in the bucket. So the crew, recreational use of internet is driven primarily by video, and video is 90% of all the traffic on the internet today.
Gotcha. Today's vessels are ripe for remote monitoring and other things of the internet solutions. Where does the maritime industry stand on the evolution of connected ships to true IoT at sea?
Well, what's starting to happen is that people are starting to transmit the data, which is really kind of the first step, and it's happening very slowly. But in order for this to really take off, what has to happen is that you have to create an ecosystem of data that's standardized. So there are new international standards for data in the maritime. This 19848 standard, which is specifies. So if a data is transmitted from pressure on cylinder number 2, there's a data label for that people have agreed to use. So in that standardized format, now you can imagine where the data gets transmitted off the ship, it can go to the cloud and anyone can access it. Because at the end of the day, the people who are running these shipping companies aren't really the experts in every piece of equipment that's on board.
Right.
So, what you'd like to do is to have a centralized data repository, and each expert, so the ecosystem of IoT companies can provide answers. So ship manager doesn't want to look at a pile of numbers or a pile of data. He wants to be told, okay, this is your route. This is, you need to go 2 RPM slower on the main engine, for the next 6 hours, or whatever, the answer is to save the fuel or save the money. And if there's a problem with the equipment, you want the equipment manufacturer to be able to just pull the data from the cloud, not try to figure out how to connect to the equipment on the ship, how to transmit the data from the ship, which requires screwing and gluing and going to visiting the vessel. So once that ecosystem exists, then suddenly I think this whole thing is going to take off.
Gotcha. So how long have you been in business?
We've been in business for about 40 years. As a company, we like to think of ourselves as an innovative, technology company. So what we do is focus on innovating, new products. And when we started, our first product was a digital compass. We actually invented the digital maritime compass. So that's how we got our start in maritime. From there, we developed the world's first actively stabilized antenna. Before that, antennas were physically stabilized by flywheels, like a motorcycle type, spinning device. So from that to VSAT, we just introduced the world's smallest VSAT, the V30, which opens up new markets for commercial tugboats and fishing boats and things like that. So really what we try to do is stay innovative, develop some new business models like our agile plans, where you don't need to buy equipment. We just provide the service. We just solve the problem and give you connectivity, and you don't have to worry about how it's done. Outside of maritime, we're also doing some interesting things. We've developed this photonic chip for self-driving cars for super accurate heading and position information. And some of that will be translating back into maritime with new low-cost fiber optic gyros for ships.
Wow, it's amazing.
So-
I watched a video on the company the other day, and it's pretty significant, the different fields that you're in, the technologies that you've grown, and the services that you provide worldwide. It's impressive.
Well, it's an interesting, time to be in business because there are a lot of, change happening in the industry, and generally that's a good time for innovation. People are looking to solve problems in different ways. So and connectivity is going to be a big part of that.
Yeah, and we've seen that transpire over the last year and a half. We thank you very much for spending a little bit of time with us and telling us about what's going on in the industry. It's always been a mystery to me, and I think it's pretty exciting to learn a little bit about the technology. I'm sure many people will appreciate your insight, and I want to thank you.
Thank you, Tony. Anytime.
Yeah.
Thank you for listening to In the Know, the Maritime Executive Podcast. We hope you'll join us again for our next exciting industry discussion. In the meantime, you can visit us at maritime-executive.com for top news on critical maritime issues.